right, so from where we ended off in the first video, what I want to talk about in this video is the basic components of a solar system and what that entails. I'm going to try to simplify it as much as possible, and I'm also going to try to focus on not everything because the scope is, pretty big. I'm going to focus on an off-grid modular system for residential use because that's what I'm going to do. And I'll talk about what's modular and what's not. I made this diagram to kind of talk through what the different components of a solar system are. The basic system starts with solar panels. You have solar panels. So in my case, I have a 5 kilowatt, 500 watt panels. The 5 kilowatts is made up of 500 watt panels. Their 100 watt panels are like 5 to 8 months old. I found a manufacturer after a lot of headache is honest and has high quality products, but I'll talk about that later. There's I have 2 arrays of 5 panels each, so a total of 10 kilowatts, or a total of 5 kilowatts solar panel. So 5 kilowatts is like the maximum power that it could generate. The solar panels puts electricity into your house through wires, and it goes into a charge controller. The purpose of the charge controller is to charge your batteries. So the charge controller will pull power from the solar panel and put it into the battery bank. In my case, I have 2 10 kilowatt batteries that are connected in parallel, so 20 kilowatts total. The charge controller pulls power from the solar panel, and the job of the charge controller is to make sure electricity is put into the batteries at a constant rate. That a step back, the solar panels don't generate 500 watts of power consistently. When the sun is highest in the air, they generate more. When the sun is lowest in the air, or lowest in the sky, it generates less. So the power that the solar panels generate isn't consistent. But the charge controller's job is to make sure your batteries aren't overworked, right? Like where you're putting so much electricity into it that you're going to burn the batteries down. So the charge controller has a very important job. It monitors electricity going into the batteries. And then, so this whole system is DC power. I was thinking about going into details about what DC and AC power is, but there's tons of videos out YouTube and other places that explain what DC and AC powers are, what amperages and voltage are. Maybe I'll make one. I don't know. But right now, this whole system is DC power. There's a thing called an inverter that pulls the DC power and converts it to AC power. In the US, most of our appliances run off of AC power, and it's a lower voltage. So it has to convert this high voltage power into a lower voltage that could then supply appliances that we use, like computers and microwaves and such. Some products or some appliances, like an electric stove, or if you have an electric dryer, they require higher voltage. So essentially, you do need that 220 volt power. So the inverter will power those different appliances. This particular inverter I got, the 30 kilowatt inverter, I mean, so much more power than what I need. I'm in like the 5 to 10 kilowatts of power at any hour during the daytime. So I don't need anywhere near that. But the purpose of the inverter is, like, even if I do grow out the system bigger, I don't need to worry about it. I'm not concerned that I'm going to overload it or pull too much power and the whole system is going to get hot. But really, the inverter's job is to convert the DC power into AC and put it through your breaker box. Really, that's what your system entails. This is what a solar off-grid residential solar system entails. There's solar panels, there's a charge controller, there's batteries, there's an inverter that pulls from the batteries that supplies a breaker box. So this is the utility company. The utility company will pull or push power to your breaker box, right? So if you didn't have this, your breaker box supplies like appliances throughout your house, right? In my system, I'm not going to do anything with the utility company. This is going to be a completely off-grid system that I'm going to put into my house. And the main reason for that is, like, I don't want to go through permits and all that stuff in Pennsylvania. You could have an off-grid solar system that's not tied into the utility company, and you don't have to worry about anything. So that's what I'm going to focus on at my house. Overall, like the system is really easy. There's not a ton of parts to this. And, all this nonsense that the solar industry is feeding is like, oh, it's complicated, it's dangerous. Okay, so take a step back. It is dangerous. If you don't know what you're doing, please get an electrician. Like, I'm not doing the circuit breaker part. I'm going to get a licensed electrician to make sure I'm not screwing anything up. I watched some videos and I did some stuff on my circuit breaker, and it seems pretty easy, but I don't know, after like messing around with the circuit breaker, I just want to I don't want to burn the house down, right? Like each part of the system, I'm going to manage separately. Like, so I'm going to hook up the solar panels, charge control, and battery, an isolated system. I'm going to do load tests, capacity tests, amperage tests, resistance test. I have a thermal bridging machine. I have a heat gun. I'm going to do measurements and make sure I'm not overheating anything. And then if all that goes well, then I'll connect it to the inverter and I'll hook up appliances. Not going to do this part. I'll hook up some appliances, make sure I don't, this stuff it's still overheating. It's still going to do my normal checks. And then if all goes well, then I'll pay an electrician to come in and put in to do the wiring. By the way, they also sell inverters that you can pull electricity from the utility company to charge your battery. So if you're on a cloudy day and you can't generate enough electricity, you don't need to worry about losing power, right? Actually, in this whole system, you don't need to worry about losing power from the electricity grid because you're not pulling power from the grid. You're pulling power from your batteries. So the batteries is what gives electricity to your house. So during the day, the solar panels will bring electricity in, put it into the batteries, and you'll pull electricity from batteries. At nighttime, there is no sun out, so you're not generating power, but your batteries are still full. So you could supply energy into your appliances that you are running at nighttime, your security camera or refrigerator and stuff. They're all pulling power from your battery. I know 20 kilowatts is not enough power for my house. But that's the other part of this. I did talk a little bit about other solutions. So they do make a solution where you could have your inverter and your charge controller in one package so that you greatly reduce the complexity of your system, because now you only have like 6 wires total to plug in and you have power. A lot of RV guys do that. If you're going camping, you could do that. But for residential use, the reason why I went through this modular approach is that I could expand this based off of what my need is. Like, let's just say I want to add another 5 kilowatts of solar panels. I could get the solar panels, get another charge controller, and hook it up, and I'm fine. If I want another battery, I could get another 10 kilowatt battery. I could get another charge controller, hook it up, and I'm fine. Initial investment, and I paid about $10,000 for the whole thing. Not even that much. I think between $6,000 to $10,000. I've lost track now, because I did some research into manufacturers, and it was a blunder. That was a lesson learned. Anyway, I figured out how to find good manufacturers through that, so it wasn't a wasted effort. I figured out, when you're talking to a manufacturer, what questions to ask them to make sure you actually get what they're sending you. Expand the system without spending a ton of money. With those inverter controller combinations, there's like inverters that are up to 5 kilowatts. Each of those are like $1,000 or $2,000 a piece, so you have to pay for that. And so if I wanted to expand it, just add another 5 kilowatts of panel, I actually have to buy a whole nother inverter charge controller combination. This is another $5,000 on top of like everything else I want to do, and I didn't like that. Like, I put in the $6,000 or $8,000. And if I want to spend, every year another $2,000 to $3,000 to expand my system, I could do that. And I don't have to worry about a lot of this overhead, right? Like, I put in an initial investment, and then everything after that, I'm only spending like a couple $1,000s a year to expand the system. I don't need to worry about, buying a whole nother inverter. Like the inverter that I got, I'm never going to outgrow that. And it's actually very, very modular. So like if something breaks on it, I could actually fix it, and it's really easy. There's the inverter, basically it's a huge transformer. I got a low frequency one, so it's a huge transformer that just the voltage, the DC voltage, and converts it lower. It's all modular, so I could work on that stuff by myself. I don't need anyone's help. I could talk to the manufacturer and get pieces that I want. The charge controllers, They're cheap. If I want to buy another one, I could put that in. If they die, I probably won't even fix it because it's so cheap. Like I'll just replace it. And the battery bank, really, the battery is the most expensive part of this. But I found a really good manufacturer that gave me a deal. I'm super excited to get my system up and running. Like my plan is to post videos as I'm doing it. So if I screw up on something, I'm gonna post that. I want people to see like the challenges that you go through when you're trying to put a solar panel or solar system together. So I'm not going to try to fluff it or anything. As I'm installing it, I'm gonna post videos, and hopefully you learn from my mistakes. And if you have comments, or if you have questions, or if you have a better way to do it, please let me know. I would love to engage with other people. I've been on this research journey for 2 years. Really, that's why I'm making this video, because now that I've actually ordered full scale equipment, I need people to help me install it. So I have to explain this every single time to everyone I talk to. So rather than doing that, I decided I'll make a video and I could share it with people. They could just watch the video. And if I'm going to make a video for my friends to help me out, I might as well post it so I can help other people out. If you're interested in the parts that I use, like I don't want to go into details of the manufacturers I use or try to links and stuff. Like that's not why I'm doing this. I'm trying to create a channel for residential solar systems that are usually much higher voltage than like if you need for an RV and stuff. And there's really not a good channel that I found for a good series of video or someone to follow that could explain these things to me. So I decided to do it myself. So hopefully, you learned a lot. I might make some more videos about the specific voltage that goes into it. I mean, I need to do that anyway, because the batteries are 48 volts and the solar panels generate 10,000 kilowatts. So my charge controller needed to be like 200 amperages, but they're super expensive. So rather than doing that, I got 70 amperages. I'm hooking it up into parallel. So I want to double check my math. My brother-in-law is helping me out. He's really good electricity and math stuff. So I'm going to crunch the numbers with him. So I'm going to make another video to kind of explain this. So if I'm going to explain to him, I might as well post it so other people could see it. So if you like this information and you want to follow along, please subscribe. Please like my channel. Please ask questions. Hopefully we get through this together. Thank you, guys.